Okay, there are certain contexts whereby graphs are actually useful, okay, rather than our usual straight line graphs. Okay, so there are many kind of graphs, right? One of them is this kind, okay, whereby we will start looking at it now. Secondly, we will look at them again. Okay. So in this question, it says that a technician in a computer firm drove from his workshop to repair a customer's computer. On his way back, he stopped to repair another customer's computer. The distance time graph shows his entire journey. Okay, so I'm reading the first paragraph over here. Okay, so this graph is a pictorial representation of his movement. Okay, it is not a map. Okay, it is to describe, okay, the distance and the time, okay, when it travels from one place to another. So how do we understand this graph according to the context? Okay, let's read it again. It says a technician in a computer firm drove from his workshop to repair a customer's computer. Okay, so in this graph itself, we have the time axis, okay, whereby it says, so instead of an x-axis, it is a time axis, whereby it has 0, 10, 20, everything in minutes. Okay? And then in our vertical axis, it is a distance travel axis. So at the start, 0 itself, okay, this particular technician, he moved from where? From the workshop to repair another person's computer. So he actually traveled 9 kilometers from the start point, which is his workshop, to the other person's computer. Okay? So it is 9 kilometers away from his workshop. That's how we can understand this path over here for this line. Understand? Okay? Then when he is at the person's place trying to repair the computer, obviously he will be situated there, he's not moving, he will just be repairing. Correct? So time will pass when he is repairing, but he himself will not move. That means that from A to B, okay, you notice that time actually continues, but then the distance remains the same. It is a horizontal straight line, distance remains the same. You understand? Okay, so at this juncture here, okay, from O to A, traveling from workshop to customer. Okay, and then from A to B, it is where he is repairing computer. Okay, then in the second sentence, it says that on his way back, so from here he travels 9 kilometers to the computer, or rather the customer's computer. Okay, then after that he's traveling backwards. So the distance will actually decrease, okay, because it's getting closer and closer to the start point, okay, which is his workshop. That's why it is now going backwards, and this line BC is where he is traveling back to workshop. But it said that he stopped over, okay, to repair another person's computer, so therefore from C to D, he is again repairing a computer. Okay, and then finally, when it comes to D to E, we see that he is, after finish repairing already, go back, okay, to the workshop. Alright, so all the different line segments over here, it represents, okay, the kind of motion that he's going through from his workshop, okay, all the way to repairing people's computer, and then after that coming back. Alright, I'm really not sure whether what's going on in your mind. I don't see a single person copying this down. Okay, if you expect me to repeat this, I'm not going to repeat this, yeah? Okay, you only want to copy inside your textbook. Okay, don't expect that such things will actually magically repeat itself, okay, when the time comes. equation. Okay, now that we understood the graph, in question part I, okay, it says that how long did it take to repair each computer? Okay, there's a 20 cent on the floor, not sure whose one is it. Okay, so to know how long it took to repair, we must figure out that it is these two horizontal line segments that is representing the process of repairing a computer. Okay, then to know how long that is going to be, we read downwards because that is our time axis, and we see that from point A to point B, point A is at 10 minutes, point B is at 30 minutes. So it takes a total of 20 minutes. Okay, 30 minus 10 to repair the computer. But then we check, okay, that whether for the second time is it also 20 minutes. So reading off your textbook, okay, you should see that for D, it is at the value of 1. What value do you read from your book or from the textbook? Where what person's name? Okay, Ricky. I think Genevieve is school. Okay, Genevieve, can you tell me what you see from this value? 55, right? Okay, and then could you also tell me what's this value here? 35. Okay, I hope that we all can read that it is 55 over here and 35 over here. Thank you, Nancy. Okay? So 55 minus 35 is also 20 minutes. Therefore, okay, the duration, okay, of repairing, you can either take 30 minus away 20 or 55 minus 35. Okay, sorry, 30 minus 10. And that will give us 20 minutes. And that will be the answer. Okay? And then for part 2, it says how far from his workshop was his first customer. So this is the first customer, okay, AB. So from O all the way to A, we want to know how far, that is the distance. So we see that along the vertical axis, which is distance traveled, from O to A, that is 9 kilometers. Therefore, the answer will be 9 kilometers. Okay. Questions? Alright. Then now part 3 is a challenging one. Okay. For part 3, it says that find the gradient of each of the following line segments, stating clearly what each gradient represents. Okay. So there are 4 different gradients that we need to find. Right? In the first one, we're trying to find the gradient of OA. Okay, so gradient of OA means that it's this diagonal line over here. Okay, and we have learned yesterday how to find the gradient. We select 2 nice points and then we form a right angle triangle. So the 2 nice points that we could easily choose is the starting point and the ending point because they cut through the corner very nicely. And I can form a very nice right angle triangle such that my rise and my run can be read off. In this case, for my rise, in this case, okay, I will be starting from here all the way to here. That means from 0 all the way to 9. So the rise is 9 units, and then for the run, looking at the axis very carefully, it is 10 units. Okay? So therefore, 9 over 10, which is 0.9. Furthermore, it is going upwards, so it must be positive. Okay? Question did not just stop at asking you to find the gradient, it also asks you to state what the gradient represents. Okay, so we know that this motion from O to A is the motion of traveling from the workshop possible. Okay, so we must also understand that when we took the rise divided by the rise itself is 9, which is what? 9 kilometers. It is a distance. Okay, and the run is 10, which is 10 minutes, and that's the time. We know that we are taking distance in the rise and time in the denominator for the run. We are familiar with what is distance divided by time, right? What is distance divided by time? Speed. So therefore, in this particular situation, the gradient is actually telling us the speed. Okay, so that's what we can interpret from the graph. Okay, so to write that out in words, we say that the technician was traveling away from his workshop at an average speed of 0.9 kilometers per minute. Okay, why is it kilometers per minute? That is because our distance was in kilometers and our time in the x-axis is in minutes. So it must be kilometer divided by minute. Okay. Moving on to part B. So for part B, we want to find the gradient of OA. Sorry, not OA, AB. Like that. Okay, so AB is this particular line segment. And what kind of line is this called? It's a horizontal line, right? Yesterday we learned that this is a horizontal line. And for horizontal line, what kind of gradient should we have? It is 0. So no need for any calculation, we know that it will be 0. Okay? Then to interpret that, we can say that the technician stopped to repair a computer and hence the average speed is 0 kilometer per minute. Okay, so it does make sense that when we stop, there is no speed, that's why the gradient is 0. Okay. Part A already. Erase this up. Okay, and then next we look at gradient of BC. So from B to C, right? Okay, we find out what is the gradient. Okay, the two convenient points that we can choose will be the start and the end. Okay, so the rise itself, what would it be? And for the run, what do you think it will be? Let's choose another person. Mika. Okay. Your friend is called Mika, not Ushida. Alright. So yes, Kevin, can you tell me what is the rise and what is the run? Look at your textbook. This is a diagram that is not clear. See, that's the problem. Your textbook not even open. Don't know why. What is the rise and what is the run? What page is already written on the whiteboard? Kevin, what is it?
4 to 5 then how much do you want?
Yeah, then just say.
Yeah, sorry.
Yes. Price is 4 and then the run is I don't understand why you want to screen your eyes and look at the diagram on the screen when you have your textbook. Then I tell you you're in deep trouble because exam paper will be printed to you. How to read the 5 units? I think it's very worrying that you cannot see. Down here is 30, all the way to C is at what? So that's why how many units? Yes.
Good. 5 units.
Because down here is 30 to 35, so therefore 5 units. Okay, you need to wake up your idea. Alright? So it is 5 units for the run. Okay? Now, is this gradient correct? No, why? Because it's downward sloping, so it should be negative. Okay? You can leave it in decimal if you want to, that will be negative 0.8. Okay? So in order to interpret this, okay, we say that the technician was traveling back to his workshop at an average speed of 0.8 kilometer per minute. Okay, while the gradient is negative, right? The negative actually tries to tell you the direction of the movement. It is not saying that the speed is negative because we know at this juncture speed cannot be negative, right? Okay, so this negative sign is to tell us direction of going backwards. Okay, but for speed itself, it's always positive. Okay? But as you learn more of science, okay, I'm not sure whether you have touched the physics component, you will realize that there's a different thing called velocity, whereby velocity takes in direction. Not sure whether you covered that yet in science. Okay? So that's for part C. Then part D itself, again, it is actually from C to D, which is a horizontal line. So actually the answer is exactly the same in part B. Okay, so gradient is equals to 0. So it means instead of AB, it will be CD. Okay, so the explanation and interpretation is exactly the same. So part D has no difference in the answer to part B. Okay. Then the last one, okay, to know what is the gradient of the final segment, okay, what do you think will the rise and will the run actually be? Let me just call another name. Who's speaking up? I think Ernest. It's the last one standing, right? Then okay. Yes, Ernest, can you answer what is the rise and what is the run for the line segment DE? You shared with us this early this year that you have long-sightedness, so I believe you can see the screen itself. Yeah. So what is the rise and what is the run?
What is the line?
We're looking at the line DE. Yes. The rise is 5 and the run is, sorry, 5. Sure? Okay, so for D, we 5. E stops at where? E stops at, and therefore there's total how many units? So should it still be 5? So our run is 7 units. Shall gradient be 5 over 7? What should it be? Negative 5 over 7. Okay, have a seat. Alright, so the gradient is negative 5 over 7. Okay, explanation actually remains the same as just now on part C. Okay, we say that the technician was traveling back to his workshop at an average speed of 5 over 7 kilometer per minute. Okay, in this case, it's not recommended that you leave your answer in decimal because you will realize that 5 over 7 gives us a recurring decimal. And recurring decimals, we try to avoid writing recurring as much as we can because sometimes your dot not very clear. So I rather we write fraction, which is very much clearer. Okay? Okay, questions? Alright, Giselle, are you copying anything? Okay, now I want us to look at the very last question, okay, of 6.4. I want us to turn to our textbook, page 170. Okay, this is another kind of question that you could possibly encounter when it comes to reading and understanding graphs. Okay, and there is a context, there's a story to tell along with this graph. It says that Debbie works for a customizable t-shirt printing shop and is tasked to plot a graph that displays the cost of printing t-shirts so that the shop can plan the charges of their services. Okay, so this graph itself tells us how much it is, okay, to print based on this axis here that tells us the cost, and the x-axis tells us the number of t-shirts. Okay, so for a certain number of t-shirts, we can read the graph to know how much will it actually be to print. In part I, it says copy and complete the table. So you are given this table here. I'm going to erase this, alright? Okay, so this is your exercise 6C, question 3. Okay, so you have this table to be filled up, whereby n itself, okay, is 10, 30, 50, 70. So for the n value, we want to find the corresponding c value based on the graph. N actually can be found along the horizontal axis because it's labeled N over here. And then for the vertical axis, it's labeled C. So when N is equals to 10, okay, we read the graph, we see that it reaches here and the price is 100. Therefore, we fill up the table as 100 under that column with 10. Okay? Likewise, when I want to find 30, okay, we read out the graph and we find that it is 200. Okay, and very quickly when reading 50 and 70, for 50 t-shirts, how much would it actually be? What do you think, Dylan? Giselle and still lost. Giselle, can you tell me how much is it going to be? Have a seat. Okay, how much will it be when n is equals to 50? You read from the graph. 300, yes. Okay, and then finally for 70, how much will it be? Okay, let's not call this. Joven.
Wow, so puzzled.
I definitely Cory was the slower one. Okay. So Cory, can you tell me how much is it for 70? 400. Is it?
Okay.
How much will it be? 70.
Really?
400, right? Okay. So yes, that's 400. Okay. Next, we look at part 2. Okay, for part 2, the question asks, it says that Debbie notices that the cost per t-shirt decreases when more t-shirts are printed and is puzzled by the observation from the graph that 0 t-shirts cost $50. Okay? So we see that over here, when there's no t-shirts being printed, it is actually $50 itself. Okay? So why do you think that will be the case? In a logical setting. In real life setting, why do you think 0 t-shirts is still a cost? GST, no. GST must pay money, must pay first, yes actually. They breathe in the air. So breathing the air, you need to pay money. This is the cost of printing of, yes, Xavier.
The cost of the machine to print the shirt.
Yes, okay, that's one of it. Marcus, you have another? So like having the cost of the machine, yes, anything else? Manpower, ink, okay, yes. So all these kind of things, okay, renting the place itself to print, paying the workers, okay, all this costs money. So even if your workshop is not printing any t-shirt, you still have to pay for the place, okay, for the workers, for the ink and whatsoever. It is not like when people say they want to order, then you go and order your ink, your printer and all that. That will be too late, right? You must have all these things in place first, okay, before you can actually sell anything, right? So all these kind of things are what we call overhead charges. So we can say that there is a fixed overhead of $50. Okay, so what does overhead actually mean? It is the cost that is necessary for the operation. Okay, so quite often you may encounter the word overhead, and you must know what does overhead actually means. Okay, so that is actually the cost of running the entire shop.
Overhead bridge.
Okay. And then in part 3, it says to find the cost of printing 68 t-shirts. Okay, so from this graph, printing 68 t-shirts, how much would it actually be? June. Yan Hoi.
No, that's
Okay, yes, Yan Hoi, okay, tell us what is the cost of printing 68 t-shirts? Yes, okay, I hope that we're all able to see 68. Okay, down here is 65. 3 squares later, that will be 68. Reading upwards, you should find $390. Okay, so that will be the cost. Okay, and part 4, we want to see that in this question, a charitable organization has a budget of $410 to print t-shirts for the event. How should there be advice on the number of t-shirts that she can print? So if I have $410, how many t-shirts do you think we can print? Let's choose another person. Okay, just now, what's the Yan Hoi answer, right? t-shirts that can be written with $410. Okay, questions? Alright, if no questions, okay, let's skip for our chapter 6 as homework. I'm giving you a worksheet for the homework. As you wait for the worksheet to come to you, I want you to take out a piece of brown paper. Pass it down on the side.
I'm gonna show you.
Okay, take out a piece of brown paper. Ready? Does everyone have a piece of the worksheet? Okay, so for homework, I want you to complete all 5 questions. 3 of them are graph drawing. Now, one very important skill that I have not yet taught you when it comes to graph drawing is how to draw your own axis. Okay, whenever we were practicing earlier on, okay, the axis will always given from me to you. I ask you to copy exactly what I have. But you need to know how to draw and how to actually place your axis in. Okay, so I'm going to start question 1 for you by teaching you how to draw your axis. Okay? So let's take a look at our homework question 1. Okay? Are we all looking at that? Now, homework question 1 says that the table shows the values of 2 variables x and y which are connected by this equation. In part A, we want to find the values of A and B. For questions 1, 2 and 3, please do a separate graph paper, so I expect 3 graph paper to receive when you submit homework. Okay? Part A, to find the values of A and B, where should you write the answer? No. What did I teach you in class? Behind the graph paper. Okay? So part A answers behind the graph paper. So in this case, on the graph paper that you now already have, okay, at the front, I want you, okay, on your graph paper here, just write chapter 6 homework, question 1. Okay? I need instructions already. Then in part A, okay, turn to the back of your graph paper. Okay, write down for part A. We are looking at the equation y equals to 3x plus 7. That's given in the question. Okay, given in the question here. I want to find the value of A, and that is when x is negative 4. So that means that our y equals to 3 times negative 4 plus 7. I will be able to get negative 5 from pressing calculator. So therefore, A equals to negative 5. I do the same for B when x equals to 2, and then I will get 13. Therefore, B equals to 13. Okay, so that's for part A. So I'm turning back to my graph paper. Listen first. Now, on your table in your question, okay, we have already found that A is negative 5, yes, 1. Where? Find out from your friend. Okay, so we have already found that A is negative 5, B is actually 13. Okay, so in this table, I see that my x values must be from negative 4 being the smallest all the way to 4 being the largest. And then for y itself, negative 5 happens to be the smallest, 19 is the largest number. That means that, okay, when I have my graph paper, when I draw my axis, okay, let me just zoom out. From left to right, that is my x-axis placement. I must have negative 4 all the way to 4. The question gave the scale of using 2 cm to represent 1 unit of the x-axis. So that means that every 2 cm is 1 unit. If let's say I have negative 4 along this thick line over here, this next one should be negative 3 because it increases. So negative 4, negative 3, okay, because that's 2 cm to 1 unit, negative 2, negative 1, 0 needs to be here, followed by 1, 2, 3, 4. Okay, so I have sufficient space, okay, from negative 4 to 4 horizontally. Then I remember that my 0 was supposed to be here, therefore, I will put my long ruler and mark out the 0 placement by drawing my y-axis in place. Okay, so that I know left and right I have negative 4, 4. Okay, you understand what I'm doing? I'm drawing my axis, yeah? Okay, so I want you to now draw in your y-axis. Okay, so this is how I decide where to put my y-axis. Okay, ready to move on? So I should count. Okay, I should never start my negative 4 along the border. Okay, don't go to the extreme ends, it should all be inside. Okay, inside the way. Don't go to the outwards end. Okay. Okay. Next, I drew in my y-axis already. What about my x-axis? Okay. Notice that in my y values, I mentioned that it must be from negative 5 all the way to 19. And I mentioned, and in the question it says, 1 cm represents 2 units on the y-axis. 1 cm is middle square size. Okay, middle square. So every middle square is going to be 2 units. Right? So usually we don't start with odd numbers. Okay, we start with an even number. So an even number that is close to negative 5 will be negative 6. Or if you want to start from counting from 19, you can choose to start from 20. So let's say I want to start from 20. 1 cm is going to be 2 units. So if this is 20 over here, 1 cm down, that will be how much? 18. You understand? Because 1 cm is 2 units. So I'm only now counting, okay, to decide where to put my x-axis. Please don't draw anything yet. If down here is 20, then down here will be 18, 16, 14, 12, 10, 8, 6, 4, 2, and 0. Okay, so I imagine that my 0 will be here. Then going down again, negative 2, negative 4, negative 6. I only need up to negative 6 at most. I don't need to go further. So I know that at this juncture I have enough space. So I can put my 0 over here where my x-axis should be. Okay? So that is how I decide where to put the x-axis and y-axis. It is not always that your axis is right in the center, okay, for the zero origin. Okay, so I hope you understand how I went into counting to make sure I have 20 to -6 in my y-axis based on the scale. Then now I can draw and label, okay, my axis already. For my x-axis, 2 cm to 1 unit, so this is 1 unit, 2, 3, and 4. This is -1, -2, -3, -4. Okay, and in my y-axis, I will have 1 cm, 2 units, so this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, then after that, -2, -4, -6 is enough. Okay, if you want to actually complete it all, nothing wrong with that. Okay, but it is not necessary. Okay. So this is how we will create our axis. Okay. You bring this home, complete the remaining question yourself. Question 2, separate graph paper. Question 3, separate graph paper. Question 4 and 5, listen carefully. Question 4 and 5, I want you to write your answers on a piece of foolscap paper. When you submit your homework, it will be question paper at the top, 3 graph paper, foolscap paper at the last. So I should be receiving a stack of 5 pieces of paper. Question paper, 3 graph paper, and 1 foolscap at the back. Okay, when will this homework be due? It shall be due on the next lesson that we meet, and that will be next week, Tuesday. Okay, I expect the homework to be done by next week, Tuesday. Then, for tomorrow home-based learning, we are going to do chapter 8 in volume B. So next week, Tuesday, make sure you bring your homework, and also you can leave your volume A at home already, bring volume B textbook. Okay, we are going into volume B, make sure you bring the correct textbook next week.